Welcome to Lesson 5 here in the Trigonometry chapter. This is Chapter 5, Lesson 5. We are going to look today at solving right triangles. We've talked a little bit about right triangles and the special things you can do, sine, cosine, tangent, with 90-degree angles in a triangle. Again, a triangle will only have a max of one 90-degree angle. But if that is true, there's some different things you can do. Today we're going to look at solving them. We have 2 points. First, some calculator work, which will make you all very happy because all you have to do is just plug it into your calculator to find the answer. And then secondly, we'll look at actually solving everything within a triangle, sides and angles. So we are 5.5 solving right triangles. First step is calculator work. Or as our legendary 8th grade friend would say, calculator work. Calculator work, we do have just one definition, and again, I'm going to write on the board. It's a short one, so I'm going to write this one on the board for us. Inverse of trig functions. Okay, we talked about what trig functions were last lesson: sine, cosine, tangent. You'll notice on your calculator, there's also right above that button, or those buttons, I should say, of sine, cosine, tangent. Right above those 3 buttons are sine to the -1, cosine to the -1, tangent to the -1. What are those? The inverse. And what are they used for? This is what this definition is about. These inverse trig functions are used to find angle measure. So, of course, sine, cosine, tangent are normally used to find sides. For instance, you could take sine of an angle equals opposite over hypotenuse. Find a side. Inverse sine would allow you to actually find the measure of an angle. Okay, find the measure of an angle. So, they're used to find angle measure. Here's what they are. Sine to the -1, or the inverse sine is how you say it. Another name for this is the arc sine. Okay, so inverse sine or arc sine. Inverse cosine or arc cosine. And then inverse tangent or arc tangent. Okay, so any of those names or symbols there stand for the inverse of the sine, cosine, tangent functions. Okay, so sine to the -1, cosine to the -1, tangent to the -1. Arc sine, arc cosine, arc tangent. Again, they're used to find angle measures. So very helpful when you're trying to solve a whole, find everything within a triangle, is you can use these operations to find angles. All right, let's look at our calculator work here to start out. Some simple problems here to start with. They will say solve sine of x equals square root of 3/2. When they say solve, what do you think they mean by solve? Well, what is missing? X. What does that represent? What normally what number is in that spot? The angle. So they're asking us what angle, when you take the sine of that angle, gives you square root of 3/2, or opposite over hypotenuse. So when you take the sine of what angle, you find square root of 3/2. What's our answer? Well, for this we could just use our calculator. Whenever we're trying to solve for a variable or find the unknown, you always get the variable by itself. How do we get x by itself? Well, right now we have sine of x. There's no sign in here, so that usually means multiplication. So it's something like sine times x. Originally, okay, we would think, well, if I have multiplication, I'll divide. The problem is you can't divide by sine, because sine always has to be of something. In other words, sine of an angle or sine of a number. So another way I like to think of it, again, it's not technically maybe in the book, but the way I like to think of it is whenever you have to divide by sine or cosine or tangent, take the inverse. So it's kind of like the opposite. Rather than multiplying sine times that angle or sine of that angle, take the inverse or take the opposite. So how do I get x by itself? Well, I got to get rid of sine, and the way to do that is divide, or a better way to say it is take the inverse of what's left on the right side of the equation. Okay? So in other words, x, your answer, your angle, equals inverse sine of square root of 3 over 2. Now, here's where the calculator comes in. One note, you want to make sure your calculator is in degree mode. Okay, most buttons there's a calculator, or there's a button, most calculators, there's a button that says mode. You want to click that and make sure that it's not in radians, but it's in degrees. Again, we kind of go back and forth between those two modes throughout this chapter. For this lesson, when you're looking, why does it have to be in degrees? You're looking for an angle. Okay? Angles, at least the ones that we want now for this application, will be in degrees. So make sure your calculator is in degree mode. When you do that, just hit your inverse sine button. So mine is second function and then sine. And then you have some parentheses. Take the square root of 3 divided by 2. And you should get an answer of 60. Now again, our book has a couple different answers. It has 60, 120, any angle coterminal with that. For our purposes, we'll just really worry about what the calculator tells us. So it says 60 degrees. That's going to be in quadrant 1. Okay, 120 is going to be in quadrant 2. Okay, over here. For now, we'll just worry about what this gives us. It's an angle 1. Most of the problems I was looking at our homework tell you that the angle is in quadrant 1. So this is going to be your answer. So x equals 60 degrees. In other words, when you take the sine of 60 degrees, sine of 60 opposite over hypotenuse, square root of 3 over 2. Okay, we can prove that on a unit circle. We won't do that now, but we can prove that sine of 60 is square root of 3 over 2. So x is 60 degrees. All right, let's do a couple more of these. Another solve. What if they give us now cosine of x equals negative square root of 2 over 2? Same idea, get x by itself. How do we do that? Get rid of cosine. In order to get rid of cosine, you have to take the inverse of it. Okay, again, in your calculator, this should work in degree mode. We take inverse cosine of negative square root of 2 over 2. All right, my calculator gave me 135 degrees. Most of you, that's what it should give you as well. Another angle coterminal with 135 would be 225. Okay, again, but for now, we'll just stick with what it gives us there. And this wouldn't necessarily be quadrant 1. This would be quadrant 2. But that's because it's negative. That's why it's in quadrant 2 there. All right, so again, simple calculator work, really just kind of introducing you to inverse sine and cosine. The main thing I want you to know from this point and these first couple of problems is that whenever you have to get rid of sine, or in essence divide it, okay, is what we like to think of in previous math courses, you have to take the inverse. Because you can't take the sine of nothing. So in other words, because we can't take the sine of nothing and just divide by sine, we have to take the inverse sine of something. Okay, so divide, or in essence, take the inverse of the sine, cosine, or tangent. All right, last couple here under point 1, that was solving. Now let's evaluate. Okay, which really just means combine down. There's not going to be an equal sign. Evaluate just means simplify down into a simpler form. Kind of simplify, but without variables. Evaluate's usually just with numbers. All right, it says assume all angles are in quadrant 1. So here's where we're not going to get those repeating answers. We'll just get our quadrant 1 answer. Evaluate tangent of inverse tangent of 6 over 11. Tangent times inverse tangent of 6 over 11. Again, there's lots of ways to do this. You can do it by hand in a way. I think our book shows us a method to do by hand. To me, we have our calculator, we have those buttons, let's use them. Okay, so these are a little easy. You can pretty much just plug this in. Make sure you get your parentheses right. Tangent, it's going to shoot up a parentheses right away. Then do inverse tangent of 6 over 11. If your calculator gives you fraction form, that's best. Okay. If not, and it gives you decimal form, that's fine. I'm okay with it for this lesson. Mine gives me decimal form, so I'm just going to write it as decimal form. It's repeating, so I'm going to say approximately 0.5454. That's going to repeat. It's actually 54 repeats there. It's actually 6 over 11. And again, the book will have some reasons of why that works out when you do it like this. But to me, we have enough other things to worry about as far as hard concepts. Since this one you can do your calculator and get the same answer as doing it by hand, we'll use our calculator since we're both there. So again, if your calculator gives you a fraction, that's fine, that's great, keep it. If not, the decimal answer is correct. So either of those would be correct. 0.54, 54 repeating, or 6/11. One more just to practice, cosine of arc sine 2/3. All right, I'm going to give you a minute. Go ahead and try to solve this one in your calculator, see what you get. I'll put it up here in a minute. You may ask, what does arc sine mean? Remember, it just means inverse sine. Same thing. Okay, once again, I got a decimal. If you got a fraction, that is the better answer. It's the more precise answer. But the decimal does not repeat. We'll just go to maybe the fourth place, the 10,000th place. 0.7, 4, 5, and then we'll round up to 4. Fraction, what'd you get? If your calculator does fractions, square root of 5 over 3. Okay, and again, what is that saying here for evaluate? It's just saying when you take the cosine of the inverse sine of 2/3, what do you get? And again, it's kind of a different example. Again, your book kind of shows some ways to find it by hand, but it's just kind of getting us familiar with the inverse functions of trig values, of trig functions. Okay, the inverse of trig functions. Inverse sine, cosine, and tangent. All right, that is calculator work. That is the quick part of today's lesson. The second part isn't that hard though. Let's look at point number 2. Point number 2, we're going to get away now from using our calculators as much. And we're actually going to go back to triangles. Okay, we're going to kind of get the theme of this lesson here, solving right triangles. We're going to call point 2 here. Finding angle measures. Okay, when I say angle measures, that is true. We'll also find some side measures as well. We're going to solve a triangle, right? First problem here, they're going to give us a right triangle. Remember, a right triangle means it has 190-degree angle. All right, and they label this for us. It is triangle FED. And the sides are the lowercase values of that, D, E, F. And we may have already mentioned it before, but remember, angles are always classified, or best classified with a capital letter. Sides are classified with a lowercase letter, and they always correspond. Angle F corresponds with side F. Okay, and likewise with all those. All right, they're not going to have us solve the whole thing here. They just tell us if F equals 17 and D equals 32, find E. Now, notice what happened here. We're looking for an angle, but they gave us two sides. Could we use a different method? Could we use Pythagorean theorem? Maybe. Okay, Pythagorean theorem does work for right triangles. However, that only works for sides, and we're looking for, note as uppercase, we're looking for an angle. So how would we find the angle E given two sides? So we're looking for this guy, and we're given F is 17 and D is 32. Well, here's where, since we're in the inverse trig function lesson, here's where those come into play. If we're looking for E, what trig function, sine, cosine, or tangent, would include both sides D and side F? Okay, well, let's identify here. What is D in relation to E? Is it opposite, adjacent, or hypotenuse? D is across from the 90-degree angle, so it has to be the hypotenuse. F is that opposite or adjacent E? Adjacent. Next to, right? It's not opposite. So what trig function would give us adjacent and hypotenuse? AH. So cosine, right? The problem is, we can't just find cosine. Let's write that out though. Cosine of E, in other words, if I take cosine of this angle, I would take adjacent over hypotenuse. 17 over 32. This looks a lot like what we just solved here a minute ago. How would I solve for angle E? Well, I want to get E by itself. How do I get rid of cosine? Divide. Better way to say it is take the inverse cosine or arc cosine. And back to our calculator. There's really no way to do this in our head other than our calculator. Inverse cosine of 17 divided by 32. What does that give us? A decimal. Is that okay? Sure. It just means the angle measure didn't come out evenly. Okay. Angles don't have to be exactly 70 degrees. Now this one's 90, but they don't all have to be exactly a whole number degree. They can be a decimal. The directions, do they say how to round? They don't. Normally you round to the nearest tenth for degrees or angles. So let's do that. Angle E, hopefully you did it and you got to the nearest tenth. (57.9 degrees). Okay, so we found angle E given two sides. And again, the inverse trig functions make that all possible. All right, that is most of today. We need one more type of problem, and these are the fun ones. Here's what they tell us. Solve the triangle. Okay, I'm just going to give you the picture and what is given. All right, there's our right triangle. Sides, or excuse me, angles ABC. Sides lowercase ABC. Here's what they give us. Angle A is 33 degrees. Side B is 5.8. Solve the triangle. What does solve the triangle mean? It means fill in all the missing parts. Fill in the missing angles, fill in the missing sides. What's missing? Most of the time with these, they'll give you three things that are missing. What are they in this case? Angle B, side A, side C. Why is angle C not missing? It's 90. They give us that. They give us that little symbol that means 90. So here's what I like to do. I like to just right away write this out. This is what I know I need to find in order to have my problem complete. I need to find angle ABC. I need to find side ABC. Once I found those 6 things, triangle is solved. Let's fill in what we know. Angle A is 33. Angle C is 90. And side B is 5.8. What should we start with? Any ideas? What's the easiest thing to do first? Find the last angle. Why is that the easiest? We know they all have to add up to be 180. So what do? Just add up 90, 133, subtract it from 180. In other words, angle B is going to equal, let's do that a little differently. Let's do it this way. A plus B plus C equals 180, right? All those angles have to equal 180. We know A is 33, we don't know B, we know C is 90. Yeah, we're kind of setting up an algebra problem. You can do it quickly in your calculator if you haven't figured out. But here's how you do the work. Add these up. 123, and then subtract 123. B equals 57. Okay, B equals 57 degrees. Plug that in. Okay. If they give you 2 angles, finding the third one's easy. You just add them up, subtract from 180. Okay. If I didn't do the work, I would just add these up, subtract from 180, 57 degrees. How do I find my other 2 sides? Can I use Pythagorean theorem? No. Why not? Because there'd be 2 unknowns. I don't know A or C. Why else could we use it? Well, it's in this section of inverse trig functions, so they probably want us to use that, or at least a trig function of some sort. Doesn't matter which one we do first, let's focus in on A. What's a method that I could find angle A? What is a method that I could use? Well, now that we know B is 57, there's a couple of different options. You can do this for a variety of ways. I'll just choose one, for example. Let's use angle A, and let's say we want to find side A. What trig function should I use with angle A? Well, side A is opposite. Could I do opposite hypotenuse and do sine? No. Why not? 2 unknowns. Opposite over hypotenuse, 2 unknowns. I only want 1 unknown. So I can't use sine. What about opposite adjacent? Sure, because I know adjacent, 5.8. What's opposite adjacent? What function? Tangent. So let's right over here. I'm going to solve for A. And you can solve for C first. You could do A a different way as well. We're going to take tangent of A, or tangent of 33. Tangent is opposite over adjacent, TOA. A over 5.8. Solve for A. How do I do that? Get it by itself. Right now it's divided by 5.8. I have to multiply by both sides by 5.8. 5.8 times tangent of 33 equals A. Calculator. 5.8 times tangent of 33. 3.7665. Again, we want to round. Let's do it to the nearest tenth again. Directions don't tell us. Tenth is usually a good rule. So 3.766 gives you 3.8. Almost done. Technically now you could use Pythagorean theorem. I'm going to keep doing it the trigonometric way. And let's solve for C. We could use angle A, we can use angle B, doesn't matter. The only danger in using, remember, angle B is that you gotta make sure you did it right. If you did it wrong, all your other answers would be wrong. Why can't we use C? Why can't we take sine of C? Well, think about it. Sine of C is opposite over hypotenuse. Opposite over hypotenuse, can't do it. Remember, you can't use a trig function with the right angle. It has to be a different angle. Let's use B just to switch it up. And I want to find C. I know opposite, and I'm looking for the hypotenuse. That is sine, right? Opposite hypotenuse. So, solve for C. Sine of B, or sine of 57, equals opposite over hypotenuse. 5.8 over C. This one's a little trickier to solve. You got to do 2 steps most of the time in order to do it right. Multiply both sides by C, right, to cancel this out. Multiply both sides by C. How do I get C by itself? Divide both sides by sine of 57. All right, again, that'll work in your calculator. So 5.8 divided by sine of 57. To the nearest 10th. C equals 6.9. Okay, again, my goal for you as we do these flipped lessons, and especially do them on the board, is for you not to just sit there, try not to be distracted by all that's going around you at the present moment, but really to work through, again, writing this down. But then also, again, today I was trying to give you some more time to find the answer first. That'll help you, because in a couple days we're gonna have a quiz or a test, and you're gonna have to do them by yourself. So working through it now and really thinking about it's gonna help you more than just simply copying down what's up here. We have solved the triangle, angles ABC, sides ABC. Is there a way to check? Kind of. You can do Pythagorean theorem, a squared plus b squared has to equal c squared, see if that works out. And then all the angles have to be 180. Again, most times if you do it right, again, they're decimals, so it's not, I can't guarantee whole numbers. But that is how we solve the triangle. And again, notice what we were given. Originally, I kind of mixed it up, but we were given just angle A and side B. That's all we were given. Now, we knew side C was 90. We're only given 2 things, one angle, one side. Last thing I want to do today is solve the triangle if only 2 sides are given. So let's go back over here. What if only 2 sides are given? Here's our triangle. Okay. ABC. These are the only sides that are given. A is 23, C is 45. That's all I know. All I know is side A is 23, side C is 45. What do I do if I only know two sides? Well, if I only know two sides, there's a couple options, okay? Can I use sine, cosine, and tangent? No, because if I use sine, cosine, and tangent, I need an angle. And all I know is C. So if I am using sine, cosine, or tangent, and I don't know angle B, once again, there's too many unknowns. So really the only option if I know two sides is to use Pythagorean theorem. Hopefully you remember it, a squared plus b squared equals c squared. So let's write it, a squared plus b squared equals c squared. That's my only option to find the third side. Okay, so I'm gonna plug them in. A squared is 23 squared. I'm looking for b. And I know c squared is 45 squared. All right, so then I can just square them, take the square root, solve for b. So 23 squared, we can plug it in real quick. 23 squared is 529 plus b squared, and 45 squared is 2025. All right, we're trying to solve for b. Subtract 529. $14.96. Let's see if it comes out even. Take the square root of our answer. $14.96. It does not. B equals 38.678. And that's okay, round to the nearest tenth. B equals 38.7. All right, we didn't write our little template. Let's do that real quick. ABC, that's what we're looking for. Sides ABC. We already knew they gave us 23 and 45. And then we just found B was 38.7. We know C is 90. Is it okay that B came out to be a decimal even though A and C were whole numbers? Yes, that's fine. All right, that may happen. Just because two are whole numbers doesn't mean they're all going to be whole numbers. So we found sides A, B, and C. Now we have to find angles A and B. Again, a couple different options. We're going to need to use sine, cosine, and tangent. We can't just add and subtract from 180 because there's two unknowns. Let's do A first. Okay, so if we're going to solve for A, I'll go here in the middle. If we're going to solve for A, what trig function should I use? Sine, cosine, or tangent? Well, now that I know all the sides, I can really use whatever I want. So pick your favorite one. For me, it would have to be tangent because everyone loves to get a tan. Tangent of A would be opposite over hypotenuse. Excuse me, not hypotenuse, adjacent. Oh, TOA. Opposite over adjacent. Okay, this is hypotenuse. So tangent of A, opposite, 23, over 38.7. Now remember, it's a good rule often to stay away from the one you found just in case you did it wrong. I'm confident here on this summer afternoon, okay, that I did it correctly. So we're going to go with it, but you may want to do opposite over hypotenuse just to be sure that if you miss this one, you don't miss A as well. Okay, this is the start of the lesson. How do we find A? Inverse, right? I got to get rid of tangent. Inverse tangent, divide. A equals tangent or inverse tangent of 23 over 38.7. Calculator, inverse tangent, 23 divided by 38.7. Does not come out even, that's okay. 30.7 is what I got. Degrees. All right, do we have to use sine, cosine, or tangent for B? We could. Don't have to. Why not? Add and subtract from 180. 90 plus 30.7 is 120.7. Subtract that from 180, 59.2. Actually, sorry, 59.3. We've solved the triangle. No matter what they give you, now they have to give you a fair amount of information, but if they give you one angle, one side, you can solve the triangle. If they give you, in this case, two sides, that's all they gave us. And of course 90, we knew that. You can also solve the triangle. Solving right triangles. That is chapter 5, lesson 5. Hope you're having a great day and a great semester. Go Eagles. I don't know what sport we're in right now, but I'm sure that we're doing great. So keep pressing on, and we will see you next time. Thanks for tuning in.